What is up, Pradeep? You're the first one here, my good man. I wouldn't say chuffed, just kind of... just looking forward to this repair. This is gonna be stanky. What's up, Clive? How's things in South Africa for you right now, buddy? What's up, Leo? Okay, you ready for this, guys? I don't know if you're ready for this. What do we got on the bench today? We've got a Taramps MD8000 1 ohm variant. This is good fun, this one. It seems that there has been a bit of a meltdown in here. Literally an absolute meltdown with melting the aluminium heatsink clamps. Seems fine. Yeah, this will work. This will still play absolutely fine. No worries. Nothing to see here. Nothing to see here, bro. Try and find a screwdriver bit to get these bolts out with. That's too big. So yeah, today's afternoon stream is going to be trying to rebuild this thing. There we go. So, how's everyone's week been then? Now, why did this get molten down so badly? Let's have a look. So, continuity test first. That's the first thing we want to do. Check output FETs. No shorts on the output FETs. Rectifiers usually don't fail. No short on the rectifiers. How about output FETs this side? No short on the output FETs this side. Interestingly, on the rectifiers we should have continuity between legs 1 and 3 of this rectifier, and it should be the same on the other side, I believe. However, that's not what we have. That's weird, because that would usually be reading the wines of the transformer secondary. So why are we not reading the wines of the transformer secondary? That's a bit strange. We're going to pull this out of the case, obviously, and investigate further. But this is a strange failure, because all of the power supplies gone down, but no dead output FETs, and what seems to be no dead rectifiers either. That's very strange. So we just have a power supply failure, and the power supply drive IC is totally bamboozled as well. I really hope and pray that the MCU is not damaged in this, because when you have a drive IC that looks like that, the MCU can be toast. So I hope that that's not the case. But in any case, let's get this out of the case and see what we have going on. What output FETs does this amp use? This amp uses... Wait a minute! What this amp's using IRFB 4115s on in an 8K. That's wild. They must be right on the edge of their breakdown limit. 4115s are 150 volt FETs. And these rail caps are 160 volts, so we know the rails aren't above 160, but I don't know, that's a little bit close for comfort. I'd rather that this was fitted with 4227s for sure. Yeah. So now we're taking off these absolute obliterated MOSFET clamps. We can't reuse any of those. That's crazy. Like fully molten aluminium. I would love to have seen that when it was melted. Molten metal looks really freaking cool, doesn't it? Oh, look at this. Oh yes, I believe, sir, you are missing some of your clamp. Damn. That's gotta be, I would say that's gotta be the worst one that I've ever seen. That's the worst condition MOSFET clamp that I've seen so far. Ever. That's ridiculous. By the way, if anyone got like a million videos from me in their subscription feeds, apologies, I wasn't hacked. I just decided to make public all of my old live streams. They were all unlisted, I think, in a playlist, but I just thought, ah, fuck it. Now that YouTube actually separates videos from lives in your channel feed, I thought I'll just make them all be public. But I didn't realise that that would clog up everyone's subscription feed, so sorry about that. This one's really freaking cool. Look at that. Look at those spiky boys. That is awesome. That is crazy. So yeah, we've just got a power supply rebuild on this bad boy then. So I'm not entirely sure what caused this to fail. We have no dead outputs. This is a mono amplifier. Clives is a one channel mono subwoofer amplifier. 8,000 watts RMS, and it does actually make that much power. These do make rated power continuously, not just for a dynamic burst. They'll make 8K all day, or maybe not continuously all day, but into music. But they do clamp 8K on a constant sine wave, sine tone into a resistive load. Although technically, I suppose, well yeah, this amplifier is one channel, but technically there are two amplifiers on this PCB, because this is a mono amplifier that's in full bridge push-pull, so there's actually two separate amplifiers that are 180 degree out of phase with each other to create the full bridge mono channel. Ham is back for today. Let's see if we can get it in focus. There we go. Oh, almost. Yeah, there we go. We're in focus now. MX says, does that row of transistors on the heatsink do the same thing that the ones you find in inverters? Similar. So obviously the pure sine wave inverters are creating a 50 Hz sine wave, and they do so with PWM on one bank of IGBTs, and then a 50 Hz square wave switch on the other bank of IGBTs to flip the polarity of the sine wave basically across the load. So it's a similar job, yeah. Excuse me. Hello from Trinidad and Tobago. Hello. Good afternoon. I have a 5K sound digital amp that is making high-pitched noise. If it's making a high-pitched noise from the actual board itself, then the issue is just a transformer ring. It's actually not a problem. Like, you don't need to fix it unless it's really annoying for you. But it's just the winding spacing between the turns and maybe a little bit of loose wind that's just causing that kind of ringing sound. And you can make it stop by grabbing the transformer and wiggling them around a little bit into a slightly new position, or just disturbing the turns a little bit. And that should get it to stop. But it's not an issue really. It's not going to cause any problems. But it can be a bit annoying for sure. What's the switching frequency of a car switched from a power supply? It does vary between brands, but I would say 99% of the car amplifiers you find has a switching frequency on the power supply between 22 and 35 kilohertz. So it's just above the audio spectrum for the most part. 25 to 28 is the most common by far. I think the fastest I've ever seen has been like 50 something maybe. Not that fast. I honestly don't know how people like let their amps get this badly damaged. Like, I don't think this is a very old amplifier, this one. It's not really been repaired, I don't think. It's been repaired once before due to some foreign object getting inside and shorting out one of the rectifiers. But this board's never been out of the heatsink as far as I can tell, because all the glue over here is still perfectly intact, and it would have to have come away from the heatsink. But yeah, the amp is in like pretty sad condition, like externally. It's a shame. You see that so often. People just don't look after their stuff. Okay, I think that's all the screws, so that should now come out. And we do just need to break the glue joint that's holding the fans in. What's your take on the new digital audio process? Oh man, this heart sign on my chat is so annoying. It's in the way of like the most recent chat. Why is it there? It never used to be there. Bore off. Pro. What's your take on new digital audio processor over old school preamp and crossover? The processor is absolutely far better for like so many reasons. Firstly, there's much less chance of it introducing sort of analog noise into the signal path. Secondly, all of the adjustments are like dead accurate, digitally accurate. There's no chance of like potentiometer tracks of parallel potentiometers becoming different over time. You don't get like physical degradation of the tracks or like dirt in the switches and in the potentiometers and crap like that just over time, you know, changes the resistance values of the potentiometers and throws out your settings and your readings and stuff. So yes, digital processing is absolutely superior in every way, pretty much. I got a message today from a guy wanting me to repair these absolutely ancient old Kenwood, like I would say they're EQs, but they're not even EQs. They're like from the 80s, and they just literally have bass, treble, balance, and fade or something on them. And I was like, dude, why are you putting that in your car, man? I said there's no point in me repairing this. It's just going to cost more than the thing's worth. So I know some people really want, you know, to run like a really old school setup or whatever, but there's a limit really to stuff you should put in. Like, all that's going to do is just introduce a bunch of noise, bunch of failure points, not give him any more control than, you know, is already available on the amps or the head unit. Oh, well, there we go. We have an answer as to why this failed, ladies and gents. I don't know if you can see there, but one MOSFET has just fallen off the PCB. Let's snap a picture of that. So we have vibration damage. Vibration kills another one. This is an amplifier. Yep, this is a 8000 watt RMS mono block subwoofer amplifier. I just need to take a picture of this to show the client that his amps failed due to vibration damage. What happened with the Boom or Bust series? It just wasn't enough views on it for it to be worth me doing, I'm afraid. So basically, Boom or Bust was costing me money to make rather than making me money. It's not even about making money, but like even if it was breaking even, that would be fine. But each episode was actually costing me money and like 2 days worth of work. If the videos were getting like 50,000 views, like I was hoping they kind of would, like it's a pretty cool series. I don't know why it didn't do that well, views wise. Like I was hoping it would, you know, do pretty well, get like the similar sort of views that Amp Dinos will get, or the Fan Showdown would get, but no, the views were like maxing out at between 9 and 15k, and it just wasn't paying for itself. Yep, this is a Taramps MD8000. Although the reason for failure of this amplifier isn't anything to do with the amplifier, it's user error, vibration damage. I enjoyed it too, my man. I really enjoyed making Boom or Bust. Really good fun, but I can't have it costing me money and time, unfortunately. Maybe I'll try it again at some point. when I've got a bit of free time. There we go. I've got another. That's why we had no continuity on that rectifier, because that snapped off as well. Let's take a picture of that and show the client. Another one bites the dust. Brum, brum, brum. Another one bites the dust. And another one gone. That one's on its last legs, just about to snap off. That was this one as well here. Let's take another picture of that one. Oh, it's raining outside and it sounds lovely. Does anyone else really like the sound of the rain outside? Like when you're indoors and nice and warm and cozy and like working away and it's like raining outside, it's nice. Ah, we've got another one there as well. The camera's messing around again for some reason. Oh, I've got that error 70 again. So I was having some issues with this the other day. And I did fix it just by, I think, unplugging the battery and plugging it back in again. There we go. Just a power cycle fixes everything. And plug that back in. There we go. Damn, it's proper ring. I've no idea if my camera picks that up. My microphone's on the camera here. But that's a nice sounding rainy day, that is. Okay, well let's get all of these toasted FETs cut off the board, repair the drive circuit, and replace the rectifiers that were snapped, and then this should be good to go. It should be a nice easy repair, provided it doesn't need an MCU. Does anyone want to make some bets? Do you think the MCU's there? Let me show you the condition of the power supply drive IC down here. You know what I'm going to do? I'm going to show you it with... I've got my microscope on the main workbench here, so that I could like plug it in and show you stuff nice and close up. All I've got to do is just nick the Okay, the audio should be back now. Sorry about that, guys. I forgot that I'm using the microphones in my JVC camera, so obviously when I unplug it from the HDMI, it doesn't pick up the sound anymore. That's my bad. Can I turn on the microphone for the hat cam instead? Possibly? Mic check 1 2. So yeah, I'm just seeing whether I can change the microphone settings around a little bit. But anyway, you saw just then what I was basically saying. What I was basically saying was that the MCU here can be killed when the power supply drive IC goes down, which is this bad boy right here, because this drive IC has traces that connect directly from the drive IC to the MCU, and if 12 volts is sent up its arse from the drive IC to the MCU, then the MCU usually dies. So I don't know whether the MCU is okay or not. I hope it's not dead, because that would suck. Does the hat cam mic work now? I think it does. So the MCU, can it be reprogrammed? So it's not really a programming issue. So the MCU will like literally die, like it will get damage inside on the silicon. Then you'd need a new MCU. However, obviously a new MCU isn't programmed yet, it's just blank. So you need to program the MCU with the original kind of firmware and stuff that Taramps would have used. I don't have the abilities and tools to do that. And you have to basically reverse engineer a working one of these amplifiers and work out what all of the code was on the MCU. Fortunately, because Taramps are freaking bros and really helpful, they will actually just send you in the post a brand new MCU. So that's awesome. The same can't be said for Sound Digital or Banda. Unfortunately, if you need a new MCU for Sound Digital, Banda, then you're straight out of luck. Paris are cool because Paris don't use MCUs. Paris use an SG3525 to control the protection and power supply PWM. So that's really, really cool. That means you'll never run into this issue. I don't think you can dump the firmware because I think it's locked. I think it's locked out. I don't know anything about dumping firmware or like programming MCUs, so I could be completely wrong. But I have spoken to a friend over in the States that does do programming of PIC and MCUs and stuff, and he said that yeah, they're like locked, so or like you can't just dump it. But I don't know if there's a way around that. I don't know if that's true. I don't know anything about that kind of thing. So let's get all of the legs from these power supply FETs out. That's the first thing we want to do. Then we're going to need all new gate resistors, a new drive IC, and then we can check the MCU. What do you think, guys? Based on that drive IC, do you reckon the MCU survived, or do you reckon it's toast? I feel like they should have put some kind of DC blocking or something in between the MCU and the drive IC, knowing that when it fails this happens. Yeah, 4 gauge isn't big enough for the Smart 3, unless you've got like hella impedance rise, or you're not really turning it up much. You want to get your 70mm welding cable or something like that. I'd love to have the soldering iron cam back. That was really cool. I think I experimented with the soldering iron cam for like one stream, and it looked really cool. But it was just a massive pain in the butt to hold the soldering iron. So if I can get like a really small endoscope cam to like cable tie to the soldering iron, that would be really cool. This board could do with a little bit of preheating, to be honest. Might just preheat it a little bit just to get a bit more energy in the board. Well, to be honest, the thing with the OFC is basically just copper, oxygen-free copper, which most decent copper is anyway. So copper obviously has a lower resistance than aluminium. So the two general types of audio cable you can get is CCA, which is copper clad or copper coated aluminium. So it's aluminium wire, but then it's like got copper coating on the outside for protection against corrosion and to make a better connection. But OFC is just straight copper wire, and the problem with CCA is that it does just like fall to pieces. It massively corrodes and degrades in the elements under the bonnet and stuff like that. Copper wire does also oxidize and get corroded and stuff, so you do need to be careful. You need to treat it. You need to make sure it's, you know, the connection point is good and not loose, not open to the elements too much. But yeah, the OFC is just a lower resistance cable in general. Mike Honda, good morning to you. Thank you so much for the 10. Very, very kind of you, buddy. Appreciate that. Hope everyone this year is progressing and doing better than myself right now. Well, that's I'm sorry to hear that you're not doing so good there, buddy. Drop me a message if you like. Let me know what's going on in your ends. And thanks a massive amount for the 10. Dr. Diner, the armpit of the USA. What's that? Can't think where that is. My geography's pretty bad. Imagine having an electronic soldering iron pump. I've had 2 different types of electric desoldering pump. And once they're like up to temperature, and provided you've got some heat in the board, they are quicker to suck the holes, kind of. But then you've got to empty them and declog them, which actually takes a lot longer than just using a manual pump like this. Like, using the pump isn't actually what's taking long here. Just getting enough heat into the board so that the solder's all melted is the thing that takes long. Actually getting the solder out of the hole is literally like a split second. It's just whoop, like that. It takes like 2 seconds. So because I've got really, really good with the manual pump, an electric one actually doesn't really speed things up too much for me. Maybe on a really, really low thermal mass board, perhaps it might be a touch quicker, but then obviously you've got the initial cost of it, and you still want to empty it and clear it out. Kansas City, I see. Good morning, Mike from Texas. I suppose for a lot of you guys in the States, you're kind of just waking up at the moment, aren't you? It's like morning time. Thank you for the stream. It helps with the times right now. I'm glad that I can help you out in one way or another, buddy. For those that have recently joined, this is a Taramps MD8000. Reason for failure, vibration damage. Oh, it's 8:15. Heck, no wonder there's not that many people watching. Most of my viewership does come from the States, so if it's like super early, then that does make sense. I tend to do like my evening streams perform way better than my daytime streams, but sometimes it's just not convenient streaming in the evening. Sometimes I just want to do a relax, you know, hang out. These pumps drive me crazy. Maybe I'm too dumb for them. The reason probably that it's driving you crazy is that you don't have a silicone tip on the end. Honestly, it makes the biggest difference. Just going from having that plastic tip on the end, which sucks. Well, it doesn't suck. I mean, it does suck. It doesn't suck well, which sucks. But putting a silicone nozzle tip on the end makes these so much better. Like, completely transforms how they perform. So I recommend doing that if you haven't already. And from Queensland, Australia. G'day, mate. Cheers for watching. Knock the top off a frothy for me. What time is it in Queensland, Australia right now? I remember when I was in Brisbane, the time difference was like almost dead opposite to the UK. Like trying to get in touch with family and friends and stuff like that, I'd be just waking up and they'd be like already asleep, and by the time that they were waking up I was asleep. So it must be pretty late in Australia right now. That's right, yeah, Alexander. I've experienced that as well. It is just literally, yeah, it's to do with how well sealed they are inside, because obviously they need to create a proper, really good vacuum, and then obviously a tighter spring will perform a better, faster, more rapid suction action, which is better. Oh, it's 12:17 AM. Wait, that's like, hey, that's midnight, hey. That's like sleepy time. Yeah, silicon will definitely have enough heat resistance typically anyway. Silicon's very heat resistant. That's why you find like cooking utensils made out of silicon and stuff like that, because they, yeah, silicon doesn't really care too much about the heat. Just getting the diameters right. I just was very lucky, just by virtue of the fact that my soldering iron tips that I buy, they have a silicon tip on the end of them to protect them, and it just so happens to be exactly the right diameter for my desoldering gun. Clive says, I think a higher thermal mass soldering iron will help you. How about something like this? Ta-da! That's a big boy, isn't it? 200 watt Weller from 1992. But no, the thermal mass of this iron is fine for these little pads. It's not a big deal. I just wanted to get a little bit more heat in the board. I only use that massive 200 watt Weller when it comes to desoldering transformers, inductors, terminals, stuff with like stupid amounts of mass. The Weller also takes a little while to heat up, so I tend to just grab this one unless I know that I've got a massive thing to do. I'll use the Weller if I'm desoldering TO247 AC package components, like a lot of them from a really big Korean amplifier or something. I'll use the Weller, and I might even use it for things like this. But I'm just kind of taking my time today. I'm just kind of chilling, not in a mad rush, so we'll take it easy. What do you do with the FETs you remove from amps that actually work? That's a really good question. So any MOSFETs that I'm removing from an amplifier that is a bank of FETs that have survived. For example, in a full bridge amplifier, you might have only one half of the full bridge amp has gone down and the other channel, or the other amplifier on the same PCB, is actually completely fine. But in the instances, obviously, where I'm replacing all of the MOSFETs for the same same batch and brand new ones, then I just put the known working used FETs just in my kind of drawers at the side here. I keep them as spares for my own projects, or sometimes if a customer brings an amp to me that's got like 1 or 2 dead FETs because of user error rather than like a drive circuit fault or something, and he's like, look man, can you just repair this for as cheap as possible? Like I don't have a lot of money right now, but I need this to work for some reason or whatever. Then I can then offer customers cheaper repairs with no warranty on the parts I replace by using salvaged FETs from known working banks of ones that I've taken. It's just another option there, because otherwise the customer might not repair the amplifier and they just throw it away, or sometimes having the cheaper option there with used parts does help out sometimes for some people. So okay, so that's all of the holes free from solder now, I believe. I think there was just one up here that's just got a little bit on the top. I'm going to just nick that off. Then we're going to turn our attention to the drive circuit. So we know that the drive IC is absolutely bamboozled, and hopefully the MCU is okay. So we're about to find that out next. Okay, let's give the board a little clean up over this side, because we have some soot over here from when the MOSFETs blew. So let's grab a towel and some isopropyl alcohol, give that a bit of a clean up. We'll need new gate resistors as well, because they're all going to be burned. But I think we'll do the gate resistors after we've sorted the drive IC and check the MCU. Yeah, using rubber bands. Yeah, well, that was the only thing that really got it to stay. Okay, so the drive circuit for the power supply is over here, so I'm going to flip that over so we can have a little look in the microscope. Have a look at our power supply driver over here. There we go. Let's get that in focus. So let's drop some flux on there and get that out. I would connect this this microscope to HDMI so you guys could see it full screen, but then my microphone stops working. Long story. So I won't do that just now, but at least you can kind of see it here. Sam, do you have any tips for cleaning rust off of traces and solder joints? Yeah, a wire brush and some isopropyl alcohol would work probably quite well. I need a nice pair of tweezers for this one. There we go, that'll do. Oh no, not those. Those are the bent ones. That'll do. I actually had to modify the microscope's working height. It doesn't come with one that's that good from factory. I've messed around with the mounts and stuff to get it higher. Because yeah, usually these are way too close to the bottom plate, aren't they? There we go. Let's drop some fresh solder onto those pads, fresh 6040. If you had to choose, what would you pick one of these amps? Taramps Smart 8 Bass or the Taramps Big Boss 8? Probably the Big Boss, but I haven't seen one yet. They are supposed to be sending me one to do a review on, so I can't really confirm yet which one I think is better because I haven't seen the Big Boss 8. But assuming that Taramps have only made improvements, then that would be the one that I would say go for. Looks like, oh wow, this trace is like really burned. Bloody hell. I think the component leg's actually come off on that trace and it's kind of welded itself to the trace. Get that off. Don't think that's going to come off, so we might just have to either cut it or solder the new component leg to it. Yeah, that's not soldered, that's welded. Okay, what I'm going to do is I think I'm just going to try and trim that off so that it's goes on the new component a bit better. Right, where's a tiny little X-Acto knife? One somewhere. There we go, that should do. There we go, so I've cut that off. Let's get some isopropyl alcohol in there, get that cleaned up. We can see what we're working with. Okay, now that trace is toast. So we're going to have to run a little jumper from this trace where that pad used to be, because that's just completely been obliterated by this chip failing. And it's also carbonised the PCB a little bit, so we just have to dig out a little bit underneath where that pad was to get rid of any potential carbonised PCB. There we go, we've found some unaffected PCB in there. Now we just need to get a little toothbrush to clean that off. Okay, no worries, we can work with that, I'm sure. Okay, so what we need to do now is with the power supply drive IC removed, we can actually put some power into the board to get the MCU running and see whether the MCU still works. The microscope's just a cheap one off of Amazon. I don't have a link for it. The link has probably changed now anyway compared to what it was. Just going to clean up our power supply pads on the back here, make sure that there's no solder bridges, so the gate pads or anything like that. Okay, cool. Time to throw some power into it then. See whether the MCU survived. What do you guys reckon? Place bets now. So we got negative on that one, positive over there, and the remote is over the other side. Ah, you guys are all nice and positive. You think it survived. I really hope it has. It's a bit 50-50 on these. When you've got a power supply drive IC that looked as burnt as that did, it's a bit hit and miss. Alright, let's get the oscilloscope turned on then, shall we? Okay, so power supply on, increase voltage, stay at 9.6 for now, and let's have a little probe then on the pads here of the MCU, and let's see whether we have survived or not. So I'm going to probe the input to the drive IC over here. Let's see whether we get PWM. Okay, we have something. It's it's 5 volts. Up to 5 volts, which makes sense. Okay, so that looks like some pulsing there. It's a little bit noisy just because I haven't got a ground probe connected, but you can just ignore that. We know that it's, there we go, that's a bit better. So that looks quite nice. From 1/2. Yep, that's doing its job. Let's check the other side, the push side rather than the pull side. Oh yeah, that looks okay as well. Nice. In that case, I would say that the MCU is alright. Thanks for that, guys, for manifesting that. That's good to see. Right, now what we need to do is obviously replace that that driver that's toasted there. So to do that, we're just going to spin this around again, get this under the microscope. And I think I've got some spare drive ICs for that location there. So let's just move that over. Actually, that might be a lot easier. You can kind of see the microscope there, can't you, anyway? If we just do that. Okay, where are we? Where are we looking for? Looking for power supply driver. There it is. Okay. So the MCU in this case produces the PWM for the power supply SMP, so it produces two sets of pulses, one push and one pull for each bank of power supply FETs. obviously out of phase from each other. It starts off with a health check mode, so it just sends some very low duty cycle pulses just to build like a couple of volts worth of rail that it then detects to make sure that the SMP is actually working and that there's no output side shorts. Only then, when it's happy that rail voltage is in fact getting built, then it sends the rest. It increases the duty cycle all the way up to just under 50%, like 47-48% duty cycle, and then that then builds the full rail. So let's have a look then. Do I have some drivers for these? Maybe they'll be in here. Oh yeah, maybe. I think that might be it. Yeah, let's fit one of these. I'm pretty sure that that's correct. If the MCU were to have failed, what would it mean in terms of repair? So you've got a few options. If you really fancy the challenge, you can buy a working version of this amplifier and reverse engineer the operation of the MCU. So you'd have to basically write your own schematic for where all the pins are connected to, monitor the MCU's operation and behavior during power up, during operation, during protection, basically spend a good few weeks probably reverse engineering the MCU code and then writing the code from scratch and programming it to a blank MCU. Or you could just get on the old emails and contact Taramps, who will send you a fully programmed MCU for this amplifier. Because Taramps are good bros and they will do that for you. Not all brands will do that. Very few brands will actually do that. So that's really cool. So a little bit of flux on there. There we go. Now what I'm going to try and do, because this pad is badly damaged over here, I'm going to have to maybe try to solder this ever so slightly off center so that that pad, the leg, reaches that kind of pad that snapped. I think I should have enough reach on the legs. Let's just check firstly that we're in the right way round. So our number 1 marker is over there, yep. So do I have enough reach on the legs? Are they long enough? So if I just go, oh yeah, that's going to be absolutely fine. Looks like we'll just have about enough reach there, and if not, I can just run a tiny little jumper wire from that trace that's broken there. Is it a stock MCU? I'm not sure what you mean by that. Taramps have made their own firmware and programmed it, so you can't just buy it from a supplier. You'd have to, like I say, either reverse engineer Taramps' firmware yourself or get them to send you one, or work at Taramps, I guess, would also be a way to do it. Go and get a job at Taramps and steal the code. No, don't do that. They're nice guys, Taramps. Okay, we're not 100% millimeter perfect, but we are on all of the pads. I'm just going to drop a little bit of flux on this one here to make a connection, little bridge over to that leg. Oh, so the MCU in this, the model, let's have a look. It is, I can read it. It's from the PIC family, I think. or always used to be. I just need to get a little bit of thermal paste and rub it over the lettering so that it shows up a bit clearer. There you go, there's a little trick for you. Actually no, it looks like this isn't from the PIC family, I don't think. I'm not sure if you can read that. Yeah, not sure. No, it's not FPGA or anything like that, no. Yeah, Taramps were using PIC family MCUs for a while. What happened last night, all I did was I just made public all of my old live streams. I didn't realise it would be such a headache for people, sorry. But all of my old live streams dating back like 6 years ago were all like unlisted. So I just made them be public. But I didn't realise that it would fill up everyone's subscription box. So yeah, sorry for that. No, I'm not happy with this. I'm gonna drop some more flux on and reposition it with the hot air gun. This is actually so much harder doing this while also trying to film it nicely. It's much easier just doing it without all of the cameras and stuff. Right, that's a bit better. A little bit more flux. I just want to make sure that trace and leg there is like actually making a really good connection, the one that had the missing pad slightly. Okay, there we go. I think that's good. Let's do some isopropyl alcohol and clean that up a little bit. And let's just get a little leg pusher just to check that everything is soldered really well. Especially that end one. Nice. See, that end one's not soldered. It's just a little too short. So I either need to make a tiny solder bridge there, or I need to just get a tiny piece of wire, magnet wire or something, just to make that connection. It's just a little too far away, that one. Because I've got so much flux on the board, it's actually quite difficult to make solder bridges, even this tiny. Like that's probably, I don't know, a quarter of a millimeter. It's like it's such a tiny bridge. Look, it wants to make a bridge between the legs, but not between the bloody pad and the leg. Come on. Don't make me get my solder wick out. There we go. And then you on the end as well. I see you there. Right, that's it, solder wick's coming out. There you go. Now to jump over this this gap where the trace is broken from where it got burnt when it's failed, I think I am just going to scratch away a little bit more at the trace and use a little piece of component leg instead of trying to do a solder bridge, because the solder bridge isn't working for me today. It's too much flux on the board. Even when you clean it up, it doesn't want to sit across the tiny gap there. So I'm going to use a little bit of component leg, I think. Scratch away, get a little bit more trace available for us to solder to there. Let's just tin that trace. There we go. Now because I've sprayed isopropyl, I'm just curious, will that now let me jump over to the leg? Probably not. Probably not. How about, actually, one trick that I have done a few times in the past is using the hot air gun and the solder wire here to kind of make bridges, and that has actually worked really well in the past. So let me just give that a quick go here. Let's get this all preheated, because the gap is like so tiny. It's like a fraction of a millimeter. We don't need a component leg. It should just be bridgeable. Oh, there we go. We bridged it, but it's miles too big. Go from one bloody extreme to the other. That bridge is ridiculous. It's like a big fat chonky boy. Oh, there we go. We can pull it away a little bit. There we go. There we go. There we go. That'll do. It's a tiny bit blobby just on the actual trace itself, but above the pad it's fine. I don't want to touch my iron on it, because if I do, it'll just break over the gap. Right, isopropyl, clean that up again, and now we can turn our attention to the gate resistors and so on. So, this board has obviously gate resistors by each of the power supply MOSFETs, and that's where the gate drive will come through that to the gate of the MOSFETs. So we need to make sure that all of the gate resistors are within tolerance. So this amplifier uses 10 ohm gates by the looks of it, by the power supply. Yep, 10R0. So we just want to make sure that we have about 10 ohms. My test lead resistance today is about 0.8, 0.9 ohms. So we need to factor that in when we're reading these gate resistors. So looking for about 10.8 or thereabouts. Yep, 10.7, 10.6. I don't think this bank sent any current down the gate path. I think the other banks did though. Or maybe it did. I think what we're going to do actually is just replace all of the gate resistors, just because so many of them were bad. So we need all new 10 ohm gates. This is a Taramps MD8000 1 ohm version. This failed not because of any reason of the amp's fault, this failed due to vibration damage. The customer had this mounted to the box, and all the MOSFETs and the rectifiers were all snapped. So this is a user error. I like removing the gate resistors like this with the iron, because it removes the gate resistor and it tins the pads ready for your new resistors in one sweep. This bank over here was the one that was burned the worst. This is the one that melted the aluminium. Okay, so now we just need to drop some new flux on the gate resistor pads, and we can put some new 10 ohms in. The gate resistor value isn't like super critical. You can, for this amplifier you barely use anything from sort of 10 ohms up to around 47 for most power supply FETs that you can drop in here. It'll be absolutely fine. Power supply FETs that this uses from factory are IRF 1404, but it's not critical. What's the difference internally between the 1 ohm and the 2 ohm? Well, the 2 ohm has double, no, not necessarily double, but it has a lot higher rail voltage than the 1 ohm version. So the 2 ohm version has higher voltage inside, and it has lower current output FETs, and it has slightly less rail capacitance. The 1 ohm version has bigger rail capacitance, higher current output FETs, but lower rail voltage. And differences to the protection circuits and stuff. Different transformers, so obviously the things that will be different are the transformers, rail capacitors, output FETs, protection stuff, few service mount resistors will be different. Right, let's find some 10 ohm gates to drop in place. These 10s? Yes they are. How many do we need? 1, 2, 3, 4, 5, 6, 7, 8, so we need 16 in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Very nice. Very good, very nice. Let's count down from 16 to 1. This is number 1. Solder melted and in. Number 2. Solder melted and in. Number 3. Solder melted and in. Number 4. Very nice, melted and in. Number 5. Melted and in. I actually much prefer working with surface mount than I do through hole. It's much quicker. Like, how quick is this? That's 8. I've got to do the 8 on the other side. Oh, sorry, no, I've already bought Perry's guide. I bought it years ago. But I actually need to go through. Oh, hang on a minute, there's somebody at the front door. Just bear with me for 1 sec, guys. This is the thing with streaming during the day. Bear with me for a sec. Well, that was another amplifier to repair, so we can crack that open and see what just got delivered, if we can get this Taramps up and running. But yeah, Perry's guide has received some updates recently, and I want to kind of go through and see what's been added. I want to see whether any of my tips and tricks have been added on there. Be kind of interesting to see. Three more to go on the gate resistors, and then we can see if our new drive IC works. See if it's the correct part that I fitted, because I just kind of eyeballed it. I thought, well, there's only one type of power supply drive IC that's in that exact smaller package that I would have bought, so it would be for these amplifiers. So I'm hoping that that was correct. Alright, here's all the new gates. One thing that's worth checking is just that you do have continuity between all of your gates on parallel banks. So, yep, 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 yep. And across this other side, yep, yep, and then, yep, yep. And then, yep, yep, and yep, yep. Okay, cool. So we have continuity between all parallel banks. That's good. Let's flip this back round. Let's just get rid of any solder that might be on the pad here. Go. Okay, looking good. So now we just need to power this up, make sure that we have PWM making its way all the way to the MOSFET gate pads. I'm sure provided the driver that I fitted is correct. So we shouldn't, hopefully, need our hot air gun anymore, so I'm going to turn that off. Okay. Oh, one thing which I do need to check is because the power supply drive IC was so badly burned, it's likely that the resistors leading up to it for VCC, that supplies power to the drive IC, might be damaged because it was very badly burnt, so it definitely drew some pretty high current. So let's just zoom in on that area for a sec. I'm not going to do the microscope just because that's kind of long. Just do a quick little zoom in there and see whether we can see any burned resistors. Ah, there's a couple actually that look a bit bad over here. 4.7 ohms. Yeah, there's a couple of 4R7s there that don't look too happy. So we need to replace those for sure. I'm just going to double check that's probably in line with the supply to the... is that in line with the supply? Is that one ground? Okay, there we go. Well, there's our supply to the drive IC, and that's a burned 4R7, so yeah, we'll definitely need to replace that. And what about this one? Damn, that one's also very high. What does that supply? Okay, that looks like both of those are in series. Got a couple of 4R7s in series there maybe. So yeah, let's replace those. Damn it, I just turned my hot air gun off and I'll have to turn it back on again now. How dang it. Let's replace those. R7. There we go, a couple of 4R7s. Put them on the rail caps. 1, 2. One, 2. A little bit of fresh solder on the pads. There we go, a couple new 4R7s, that should be it now. BCC, there's no other burned resistors in the output section because the output section was not part of this failure, so that should all be absolutely fine. Auxiliary supply voltage, boost converters up here, these are probably all fine because that wasn't part of the failure either. So yeah. So we are all good. There's a cap that maybe has a black hole. Maybe this one. No, I think that's just a little bit of grit on top. I do see what you're saying, but no, it's just like a little bit of dirt. The capacitors don't fail in these kind of failures, so we should be fine. Okay, so that should be it for the hot air gun now. Let's turn the power supply back on. I'm going to limit the current quite drastically here to about 1 amp. Okay, there we go, 9.6, and there's no idle current draw. Let's make sure there's no DC on any of the gate pads here. The scope do be kind of noisy today. Some days it's worse than others. See that noise on the scope there? I think it's just because my probes are kind of janky. I need to buy some more probes really. Anyway. So we have 12 volts up on the drain pad. Gate pad has nothing on it, that's good, that's what we like to see. So if we hit the remote now, we should hopefully see pulses going to the gate pads. There we go, lovely stuff. That's what we want to see. Tiny little duty cycle pulses on the push bank, and we need them also on the pull bank. There we go. Very, very nice. So I would say that's our drive circuit repaired now. We just need some new power supply MOSFETs, and we also need to replace the rectifiers that had snapped off from vibration damage. Cool. So power supply FETs, this uses 1404s. Let's see, what have we got? There's some 1404s which we could drop in. Yep, that'll be fine. I think I also had some slightly beefier ones somewhere, not that it really needs yet. No, these are weaker ones for smaller amps. Yeah, just put some 1404s in, why not? I should send the pictures of the snapped MOSFET legs to the customer just to see what he has to say. So let's have a go. So these are, if anyone sort of joined recently, this is why this amplifier failed. Oh, it won't. Hang on, I need to manual focus this camera. There we go. So we have snapped MOSFET legs there. We also have snapped MOSFET leg there. And another one there. And another one there. So I'm just going to send these to the guy who owns this amplifier and just see what he says. Ask him if it's mounted to the box or not. Where is he? Where is he? Where is he? Here he is. Vibration damage, my bro. Is this amp on the box by any chance? Laugh face. See what he says. Oh, you should ask him if it's attached to the subwoofer. Yeah, bro didn't attach his amp to the box, he attached it straight to the subwoofer cone. No, I should be right, mate. It's not flexing that much. Alright, I think he's replied, let's see. Yes, he just said, yes, relocate, lol. Good plan. The alternative, obviously, if you have to mount it to the box, just make sure the box is absolutely like rock solid and is not flexing in the slightest bit. But even then, it's still going to flex a little bit, just from the nature of it being a subwoofer, you know. Okay, that's all the FETs mounted there, just got to solder them in place now. What I tend to do like with this is I'll just tack the gate leg soldered from the top of the board here, and then I will, once they're all sort of locked in place with the gate, I'll then flip it over and solder all the other ones from the bottom. Just to stop them falling out when you flip it over. Gate, a gate, a gate, a gate. And also, before we finish this, we're going to need new rectifier diodes as well. We don't necessarily need to put new ones in, but the ones that snapped off, we can reuse those if the legs are long enough, because the diodes themselves will be absolutely fine, and they're kind of hard to come by. The MUR 1620, the common anode and common cathode, well, I think it's the common anode is kind of a bit hard to get hold of. So provided the common anode part is actually fine, which it will be, it's just the leg snapped off. They're incredibly robust rectifier diodes. You really struggle to kill them. Oh, that rain's coming in again. Sheesh. Don't know if you guys can hear that or not on the camera. Okay, so that's all our power supply FETs soldered in place. I'm just going to trim the legs, and then we need some new or repaired rectifier diodes. Probably don't actually need to trim the legs because the other solder connections on the board here are actually a bit higher than those legs, so that's fine. Okay, so we have a snapped rectifier right here, so I'm just going to remove those the remains of the legs from that and see if we can reuse the working rectifier that was in that place, or whether we're going to need to fit a new one or fit some new legs to it or something. See, yesterday I made all of my old live streams be public. They were all unlisted. I didn't realise it would appear in everyone's subscriptions feed, so apologies for that. I assumed because they were old streams that they wouldn't appear in your subscriptions. So yeah, sorry about that. So these are the rectifiers that came out the board that had the snap legs, so I don't know if there's going to be enough leg left on there. Without extending the legs maybe. Nah, that's too short. It doesn't. It voids against the. Actually, that just about works if you get the angle just right. Yeah, it just about works, that one. Yeah, I don't know. There's not much through the hole, but the leg is in the hole a little bit. It's not like fully through, but it is enough in the hole that it's actually clamped from both sides. So I think that one's going to be okay. Okay, that one's going to be alright. So now we just got to find the one that was in here. Oh, where's that gone? Those are all the power supply FETs I cut out, so let's get rid of those. Okay, let's see if we've got a spare then to drop in. So this needs to be a CTR, so it needs to be either, if I've got the U1620RG, that will work. Otherwise it'll have to be an MUR 1620. Let's see what I got. Avak says, I took all the hot glue out. Good job, buddy. You're doing well. Fantastic. I love to hear it. $1660G. $1660G. Nope, not one of those. Okay, it's going to have to be a 16. Oh no, it's going to have to be a FEP 16DT or DTD. I think it's going to be a DTD. That's the ones that face out from each other, isn't it? Oh, hang on a minute. 1620 RG. There we go. I had one left. That's the right polarity. Excellent. Okay. Let's drop that. Hey Sam, how's your day going? Yeah, it's going pretty good so far, thank you buddy. Just sorting out this vibration damaged MD8K. Almost there. Once this rectifier is fitted, we're ready for a full power up, I would say. And I think it's just going to work straight away because it was just a power supply failure. We've fixed the drive circuit and we've replaced the rectifiers, so that should be all good to go now. Yep, okay. I think that we are ready for a full power up, a full test. Test it out, see if it works. I'm sure it probably will. I don't think that there's only going to be any other faults with this. Just a dead power supply and snapped rectifiers and blown power supply drivers. Going to want all new thermal paste as well on this. It is a bit strange that this uses 4115s. I would have thought this would have to use 4227s, but there you go. Alright, well there we go. I'm just going to drop a load across the speaker terminals. Class D amplifiers don't really like being powered up and idled without a load on the speaker terminals. So I'm just going to drop 16 ohms across the terminals just for this power up, just in case. Seeing as the output section's fine. There we go. Remote. So let's go for a cheeky power up. 1.6 volts to start with. Keep it low for now. Let's check for PWM on the power supply there, which we do have. I need to up the current a bit because we're down at like 0.1 of an amp. There we go. So we have PWM on the power supply gate there. We should be building a bit of rail voltage. There we go. Rail voltage is slowly building, as you can see. Up at 82 volts now. There we go. And on the output side, yep, nothing on the low side. Positive rail on the high side. Cool, cool. I'm just going to put on my protection glasses, if I can find them. Ah, I think they're downstairs. Let me just go and get my protection glasses, safety glasses, just in case anything explodes. I'm sure it won't. There's no reason for anything to be dead on here to explode, but just in case, you know, you never know. There we go. Safety glasses are on. Okay, and we're in the low side. Let's see if we get Class D switching. There we go, Class D switching, lovely stuff. 115 kilohertz and 3 amps idle current draw, looks good to me. Let's just check the other side. Yeah, sweet. Very nice. So that's all fixed. Just got to get it back in the case now and do some endurance testing up at 12 volts and at 14 volts. Excellent. Now what arrived earlier today? It's just while that rail voltage is sinking down a bit, let's just have a quick look what arrived in the post just now. It feels kind of heavy. Let's see what needs to be fixed. How do we open this one? There we go. What's up, Timbo? Come on, back you come. Boris, how's it going? Good to see you today. Thanks for jumping on the stream, buddy. We just fixed this Taramps MD8000 from vibration damage, so that's good. Going to go back in the case in a minute. I'm just opening a amplifier that just arrived this afternoon whilst we were live streaming. Going to see what this is. This has got a lot of bubble wrap on it, this one. Okay, what is this? Ah, is that a kicker? Ah, haven't seen one of these in a while. Oh, sadly, all of the end plates all snapped. Don't think that happened in the post because the plastic isn't there. Oh wow, this sounds like there's a lot of stuff floating around inside of there. What the heck? Right, let's get this MD8000 off the bench, and I'm curious to crack this kicker open and see what's floating around inside. It smells kind of bad as well. It smells like it's very badly burned. Right, so is the rail voltage sunken back down a little bit yet on this? We have 29 volts. Yeah, that's cool. Where's my own key? Yes. Avak says, by putting extra silicone on the circuit board, will it help with the vibration? No, not in this case, because it was the MOSFET legs that snapped from the board, so it just needs more. It needs some supports down the middle of the board to kind of lock it in place centrally. Right, let's have a peek in this kicker then. see what's rattling around inside. 1500.1, nice little amplifier this when they work. Unfortunately, there's no note in the box for this. I always ask people to include a note so that I know what's wrong with it, who they are, where it's come from, because like I've no idea. I can't remember who the bloody hell sent this in. No idea. Right, what's going on in here then? Breakfast! Oh my god. What the fuck? Guys, I don't know if I can fix this. I mean, I'm pretty sure I can. Is that just power supply? What the fuck? Guys, what the heck? Oh my days. You ready for this? Fucking hell. Actually, I think this might be one that a guy sent to me for free because it was so badly burnt. I've got a feeling someone was going to send me this kicker at no cost and I could just keep it, and if I could fix it I could use it. Guys, look inside this. Look inside this. Ouch. What the heck? That has been properly on fire. That those resistors, there's nothing left of the board over this side. Wow. Well then. The funny thing is that I can repair this. There's no problem at all. I've repaired similarly damaged PCBs. The problem is that I would want to know what all these parts were. So these two resistors here, okay, that are like toasted. Trying to get a best view of this. I think they're going to be the same as these. So yeah, we're going to have red, black, brown, gold. So yeah, okay, 200 maybe? I can't remember what the colours are. Red, black, brown, gold there. So that's going to be the same over here. Then we're missing a film capacitor that was also going to be over here. So we can work out what that was supposed to be connected to. That's easy. We've got a couple of resistors here. We've got all these traces. What is that? Fuck. I don't actually know if I want to get this out of the case just now, because what it's going to do, yeah, see, it's almost ruined my legs. My legs have got like soot on them now, so I'm going to have to try and clean that off. If I get this out of the case right here, it's going to completely stain the carpet like it has done before with these kinds of blown fire ones. So I'm actually going to leave this. I'm probably going to do a separate video or separate stream on this when I'm wearing less, because these are quite nice jeans. These I don't really want to get these all dirty. So yeah, like I said, I can probably fix that, but it's going to need lots of jumper wires, lots of jumper wires and lots of cleaning. Wow, fun times. Right, let's put that to one side for a later date, shall we? Okay. Well, we can look at something kind of similar, if you like, for the rest of the stream. I say kind of similar, not similar, not a similar amplifier, just this one has burnt stuff in it as well. So this is a Vibe. We have a brand over here called Vibe, and this is, you'll have this over in the States as well, just under a different brand name. This is a 4-channel Class D. I think it does like 200 watts, 280 watts per channel Class D into 2 ohms or something like that. And these get damaged, well, when the output FETs blow, they kill the driver, which is a 2092, and the driver then kills the rectifier that's supplying 12 volts reference negative rail to all the drive ICs. That then kills that the rectifier diode, and because the rectifier diode shorts, then because it's then shorted, the AC that the rectifier diode is supposed to be rectifying then gets sent to all the rest of the drivers, so it kills all the drivers because they're then getting like AC. So yeah, bad times for this is a very annoying poor circuit design, the fact that happens when it fails. So let's get this out of the board and see what we're working with here, shall we? We have some burnt traces on here that you can see already. So the traces here on the board, these traces lead from the transformer auxiliary winds on the secondary here. They lead from here, over here, through to this diode, which I've already removed because it was shorted. And that diode then feeds 12 volts reference negative rail to all of the 2092 drivers, which are on these driver cars. Now these little heat sinks that have been glued on to the driver cars, that's factory. They do that in the factory because the 2092s run kind of hot in these amplifiers. So Henrik says, hello Bev, just watched your inverter video. Great stuff, thank you very much. I put some effort into that one, and it was a bit of a headache repair, wasn't it? But we got there in the end. What's the best budget amplifier for 5,000 watts RMS? Probably a Taramps Smart 5. Smart 5 bass would be a really good option. They're very budget friendly, like 5k for how much they cost is very, very good value. So get a Smart 5 bass or the Big Boss 5, which is probably coming soon if it's not already out. Or even like an MD 5k would be fine, or a bass 5k. I'm a massive fan of the Taramps stuff. If you can get it in your location, if you can get these amps in your country, get a Powerus PW5000. Absolutely phenomenal amplifiers. They're better than the Taramps for sure. So if you can get a Powerus, get a Powerus. If you can't get a Powerus, get a Taramps. And if you don't want to get a Taramps, then, well, hopefully you've got deep pockets, because everything else worth buying is like 4 times the price. And not necessarily for any good reason either. Second question, I've already purchased Assault 2. Why did you do? Why ask then? See if you can get a return on the Assault 2. They're just stupidly overpriced amplifiers based on really old-fashioned technology. So try and sell the Smart 2 or get a refund or send it back and buy something that's actually good power and good technology for the money. Sorry, Matt. I'm not a fan of the Salt amplifiers. I'm not a fan of the Digital Designs M series amplifiers. They're really freaking expensive for no reason. It's all just expensive old Korean tech. I have lots of magnets laying around my table for holding screws. Lots of screws, yeah. That's one way to do it for sure. Lots of magnets. Yeah, I'm not sure what you can get in Canada. I don't really know what the Canadian amplifier market looks like, but if you can get Powerus, get a Powerus. If you can get Taramps Smart or Big Boss, get one of those. Oops, I think I just knocked my camera out. Rockford amps are also crazy expensive for the power. Why is it so? So basically Rockford amps are expensive. I want to get my, hang on, let me just get my Canon camera back up and running so you can actually see me. Come on. Why are you not connecting? Come on. So I guess camera's dead again. But basically Rockford are expensive because firstly there's a lot of R&D that they need to claw back. So Rockford Fosgate design all their amplifiers from scratch in-house, and that is freaking expensive. Most of the amplifiers you'll buy that are car audio amplifiers will have little to no R&D done on them. So the costs of R&D are very low. They just basically go to the factory and say, I want one of these, I want 500 of these. Slightly change the design here a tiny little bit, but Rockford Fosgate need to spend a good amount of time properly engineering a circuit from scratch. So the price that you pay for the amplifier will account for that time spent. Secondly, they are very, very good amplifiers. All the parts used are some of the best, most expensive parts used. And yeah, they're just really, really nicely built amplifiers. And if you can afford a Rockford, then if you can afford a Rockford, then it will do you well. And they're a good second-hand buy as well if you can get it for a good price. What have I done to the camera? I stretched my legs out and I touched a couple of wires down here. Okay, so do we have dead output FETs on this little thing then, this little 4-channel Class D? Is that why this happened? Okay, these ones seem alright. These ones seem alright. These ones seem alright. And these ones seem alright. So there was no dead output FETs that I can see. So it looks like the rectifier just couldn't handle it and has shorted and has probably killed the 2092s, sadly. You always recommend Class D on subs. Yeah, of course. Why would you want to use anything else on subwoofers? There's no benefits to using Class AB on subs. It's an absolute massive waste of energy and everything. You want the most power that you can get for subs. The most important thing for subwoofer application is dynamic headroom. So why would you want to limit yourself to a Class AB that could probably max the biggest Class AB you find is probably like, I don't know, 800 watts? No! 3000 watts, you want headroom, buddy. Class D, 80% efficiency. That doesn't mean you're sending 3000 watts to your sub at all times. That just means that there is enough voltage there in the rails that means you're well away from clip at all times, which is going to sound beautiful. Doesn't matter what frequency you're playing. On the kick drums you can turn the low pass filter up and it won't clip. Okay, well, I guess let's start repairing these traces then that lead from the auxiliary tap on the transformer to this rectifier diode here in the middle of the board. So that looks like it comes through this trace on the bottom. Okay, here we go. This trace is burned. It goes over there, but it's burnt, and it's the silk screen has come off a little bit there, or the solder mask, but it's still intact. So it pops up there. So let's flip that back over. Okay, that then goes over here. Yep, there we go. To there. And that again is all intact, that trace, it's not broken. It's just got so hot that the blues come off. That then goes under the board to there, which then goes round to the auxiliary tap, and that's hot as well there. So that is all intact. Let's check the other one. So we have continuity there, obviously, because it's through the transformer, so that pops up there. Okay, so that should all have continuity. That then goes through here to the here, which is all still intact, just a little bit burnt. And this trace, now this one here is the one that's broken. That trace is broken, so we need to repair that trace there that leads from that via through to this capacitor. Easy, no problemo. Do I have a little component leg that's long enough for that? I might do. Oh yeah, we can triangulate across there, easy. That trace did in fact turn into a fuse, you're absolutely right, Mr. Doctor. That trace is a fuse. Gather round, watch my magic trick where I turn trace into fuse. Oh, go on. Let there be enough there. There's like a tiny little bit. This is actually my own amplifier. This isn't a customer repair, this one. This is just one that belongs to me that someone donated because it was forked. A little bit of flux. This is just almost not quite long enough, but it'll be fine. It's just long enough to touch on that bit of trace that's left there. Gotta love it when items come in for repair with their fuses wrapped in foil. Oh, that's never a good time. You're gonna have blown traces on that kind of repair. Let's try and get this side camera working again. I don't know why it's not for some reason. Come on. Did EOS webcam utility crash? No idea. Opinion on Helix amps, DSPs. Helix make... Oh, I keep going to press that camera. Helix makes some of the best DSPs for sure. Yeah, I'd always recommend a Helix DSP. As for their amplifiers, they can be a little bit overly complicated and overpriced for what you need. But again, if you can afford a Helix amplifier, then that's going to do you well. You're gonna have a good time. It's probably going to last you a long time, and it's going to sound pretty nice. Though to be honest, my go-to for amplifiers still to this day is probably going to be Alpine. I freaking love their stuff. Their amplifiers are wicked. They just last for years as well. Yeah, that'll do. It's fine. Right, now we need a rectifier diode in here. What do we have in my diodes tub? I have a U4C, that should do the trick. Now then, I suspect that one of the 2092s is probably dead. So because we've got no dead output FETs, what we can do is we can compare the multimeter readings, when this focuses, between banks. So we've got 486, 450, it's a little bit different on that one. They should be all identical basically. Yeah, I think that I've got a funky feeling here that every single one of these 092s is going to be dead. I could be wrong. That's looking promising though. They all dioded out the same. 577, 578, 577. Okay, they all diode out the same. 450. I see this one's different. 450 versus 485. $850. Yeah, one of these is dead. I'm not sure which one it is yet. 543. I think it might be this one. 450, 485. Oh, actually, both of them might be. Yeah. Yeah, I'm not too sure. I think that I think we're getting different readings on the low side. Alright, well, let's get this rectifier diode in first, and then we can, I probably will power it up and just see what happens on each of the channels. Usually a dead 2092 doesn't actually kill the output FETs. If it's dead, there just won't be any Class D switching, so I think we're pretty safe. Right, there we go. There's your new rectifier fitted, locked and loaded. So now let's drop some power into this then and just see what the outputs are doing. Let's leave that hooked up there. Let's get that. One of these. Rob says, yes, as I think with today's quality control, if an item lasts longer than the warranty period, an engineer gets fired. Sadly, that there's probably, it probably holds a little bit of truth in there somewhere. Not quite as drastic, but yeah. Unfortunately, I think that as long as the product lasts the warranty period, that's all that matters, isn't it? Okay, so power supply time. Let's see what each of these channels is doing. I would be very surprised if we got Class D switching from any one of these. Oh, got high current draw there. Have I put the wires in the wrong way around? No, I don't think I have. No, we've got 12 volts going in there. Ground going in there. Did this kill the power supply? Well, we have a dead short between... Oh, hang on a minute. Oh, no, I think I know why. Stupid ass. My larger crocodile clips here were just touching each other on the floor because I've got to clip them back onto my little clip up here to get them off the floor after the Taramps. So now if I turn that on, there we go. That's better. Right. So I'm just going to build a tiny little bit of rail voltage to start with, just to see whether we have any DC on any of the low side drains. If we do, then we know that that side is buggered. So let's find our high side first. Okay, so these are our high sides. So we got positive rail there, positive there, positive there, and positive there. Don't think there's any DC. No, not getting any DC yet on any of these, which is good. Okay, so now I guess we see whether we get any Class D switching. we have quite a high current draw already. 1.6 amps is quite high before any Class D switching has initialized. So I'm just going to take the thermal imaging camera and just see whether any of these driver cards over here are getting hot. That will tell us which ones are toasted. I don't really want to put too much current in here yet. Let's have a look. So obviously we've got some heat on the board from where we just did some soldering. See if we can get rid of that a little bit with some isopropyl alcohol evaporation. Oh, hang on a minute. One thing I should do is a visual inspection of... I should have just checked that with my eyes first. So this driver card on the back has got, you can't really see it there because it's hiding behind this inductor, but it's got a toasted surface mount resistor there just behind. You can just about see it. So this driver card needs to come out because I don't think I can get to that with that inductor in the way. Either the inductor needs, maybe I could just take the inductor off. That would probably be simpler. I could repair the rest of this with just with taking the inductor off. Maybe I should remove the card. I don't know. What do you think? Should I remove the card? It might be easier to solder the 2092 if I remove the card. Yeah, fuck it. Let's remove the card. So yeah, everything's glued on this board. That's fine. We can just cut that off. Not a problem. We've got the driver card here. It's got a little bit of glue around the edge. I'm just going to make sure that there's no rail voltage left. We've got 2 volts of rail. That's fine. Yeah, no worries. So we're just going to cut the glue at the driver card here so that we can get it out. It's nice and easy. Same on the other side. There we go. Just preheat the board a little bit with the heat gun. Oh no! Is 16 hours repairing a Unison Research Unico amp just due to the LED. That's really strange and interesting because the Genesis amplifiers use that same method of using the LED to kind of apply a known amount of voltage drop for another circuit. It's really strange. Yeah, I had a Genesis amplifier with a dead green LED, and as a result, like nothing worked. I don't know if the power supply worked or if it was the bias supply or something. Something didn't work because the green LED was dead, and I was like, eh? Is it possible to make a simple DIY Class D amp and make a video explaining how it works and how to build it? Oh, maybe. It'd be a pretty fun project, wouldn't it? This isn't quite hot enough yet. Let's wait for a bit more heat. This is good, but it does take ages to heat up. Yeah, this is 200 watts, this iron. It's got a lot of thermal mass, so it does just take a little while to get hot. But once it is hot, it stays hot. You can touch it on like a massive thick trace and it just like doesn't care. go. Almost died. Right, so this is the driver card that we've removed. As you can see, the resistor on the back is obliterated. There we go, resistor is dead. I just want to get some fresh solder onto these onto the ends of this pad, because otherwise, because I think it's got so hot that it's kind of welded itself to the card here, so I don't think the hot air would take it off. A lot of amps do have the drive circuit on the PCB, but I think it just makes it easier for... I don't know really. Yeah, I'm not too sure. Why do amps have... I guess it's to save space on the PCB maybe. But yeah, so many amps do have the drive circuit on daughter boards like this. Most important thing on this I'm looking for is that this trace is intact. There's a little trace that runs underneath this resistor that usually burns, and it runs to this capacitor and diode. That does look all intact. So yeah, this is actually fine here. That's good. Now I remind myself, what value is that resistor? I think it's a 10 ohm. Look at one of the other ones. Oh, it's 100 ohm. I can't remember if I have any 100s that are that size, that are surface mount. I think I might have to go with a through hole. This isn't a customer repair, this one. This is just one of my own amplifiers that was donated to me, and if I could fix it, I could keep it. Yeah, so I don't have any hundreds that are that size, so I'm going to go with a through hole. I think. Provided I can find a through hole that's big, that's the right resistance. I think that's one there, maybe. I think this might be a 10. That's a 10. That might be one. Yeah, I should probably sort this box of resistors out one day, but any time that I have free, I'm repairing. So it's kind of tricky to devote like a whole, what would this be, like 4 hours maybe to go through this? Usually I can find the resistor I need within a minute, so, but I think I might have used up all my hundreds recently. Usually it's easier because I have like them on these reels, so I can easily see the what ones I've got. But the hundreds, I rarely ever buy 100 ohm resistors, so any that I do have will be like right down the bottom somewhere. Right, well there's one. It's a bit big. It's quite a large package, that one. Higher wattage rating than I really need, but it will work, it will do. There's one that's smaller. Found one. Yeah, there's one. Okay, so the fact that this one had a blown resistor like that almost guarantees that the 2092 is dead. So that's this little chip under here, under this heatsink. So let's cut the heatsink off and let's get to the chip and replace it. Now, heating this glue stuff is probably going to be really bad fumes, but what can you do? Big deep breath. Just take a breath. Come on. Why is this like not... This has been way longer than any other... This isn't even a high thermal mass board. There we go. Right, fresh 6040 I think on there, because that appears to be lead free, which is why that was so difficult to get off. Let's go up here like that. There we go. Okay, so I've actually had something ridiculous like, I want to say 12 of these amplifiers that I've repaired over the course of the last few months, and each time they needed a 209, they need like 4 2092s, so they are absolutely chomping through my stock of 2092s. Hey, how are we looking? Yeah, looks good to me. Okay. I suppose I could glue that back in place, couldn't I? That heatsink there. What I'm going to do is just pop that to one side for a minute though. I don't think there's anything else on this driver card that's bad. I could check a few other bits, so just going to have a quick little visual of a few more resistors, low value resistors and bits and bobs on here. I think that's right. There's a 10 ohm there that sometimes shorts and a 4R7. Let's just check that rectifier diode there for the high side bootstrap. Uh, 308, and should be open the other way around. Yep, that looks fine. Let's flip it over. So we've got that resistor there. There's a transistor here that's quite nearby that resistor, but usually that doesn't fail. Yeah, no, that's fine. 103, and then we've got a couple of 4R7s here. They're fine. And then 680s, and they're probably fine as well. So I suspect that's probably fine now. So I'm just going to put that to one side, because what we can do is we can power this board up with, you know, driver cards missing. So that one was obviously definitely in need of repair. The other ones though likely will be as well, but I just want to go and do a visual inspection of the 100 ohm resistors on the backs of these, because they burn quite badly when the driver card fails. And I also want to check across the bootstrap diodes, because sometimes you get a short reading across the bootstrap diodes when the 2092s fail. So let's just check this diode on the back here for this one. 670 that way round, and oh, okay, that doesn't look too promising. Let's compare that with this other driver card. Okay, that one is open that way round, that one is charging. Yeah, you know what, I think that we got a fair bit more damage here, you know. That one is that one way around. Yeah, we're getting different readings on all these driver cards, so I think that one of these at least is not functional. What I will do though is I'm just going to put some power into it and see if any of these channels start operating, because I don't want to change all 4 2092s if there's no need to. So let's just zoom out there for a sec, turn the supply back on, just double check we've got no solder bridges on that driver card that we just removed. Looks good, and looks good on that side as well. Okay, cool. Okay, so get a little bit of rail voltage. There we go. We've got slightly less current draw now that we've removed that bad driver card, so I want to see which of these channels starts switching. Any of them? None of them. No Class D switching on any of them. Do we actually have our 12 volts ref neg rail though? 11, that's 10 volts there. What's our negative rail sitting at the moment? Uh, 20, 28, 27. So that's about 17 volts there on the 12 volts ref neg rail. It's a little high actually, but you know, there you go. Oh, we have an attempt at Class D switching on this channel. Okay, well that's definitely not correct. Let's try this one. Okay, that one is bad as well. And that one is bad as well. Yeah, they're all no good. Okay, so yeah, I think we're going to need 4 brand new 2092s. Each one of these is going to need replacing. Okie dokie, no problem. Short out the rails. Get the rails down to ground. There we go, no more scary rail voltage, not that it's that scary in these amplifiers anyway. So, these are the driver cards. I don't really think I need to remove the whole card. I should just be able to replace the 2092s with them in place. I do that usually with these cards because there's quite easy access to the 2092. So, I'm just going to cut away the adhesive for the heat sinks on each of these. And then we can get the 2092s out and drop new ones in and then see if that works. It should do. Okay, that's that one. That's that one. And these ones at the back have a couple of little capacitors kind of in the way, so we need to be a little bit careful that we don't overheat those when we're using the hot air gun. And that's that one. Okay, so let's get to removing these 2092s. I'm going to flip this board over so it's easier to see what we're doing. Visuals from the front, there we go. Move this out of the way. That cam I think is going to be the easiest one for you guys on this. Yep, there we go. Just get something under there to hold that up a little higher. And then we just want some, yeah, you can't really see what I'm doing here, can you? Because the board's kind of angled in a way that makes it difficult for you guys. So maybe if I do that one, no, you still can't really see the 209s. Maybe just like that we'll have to do. So yeah, we're just basically removing the 2092s from these other drive cards here. Got 1, 2, and 3. Go. Tweezers. Where are my tweezers? Here we go. Hiding behind the microscope for some reason. Right, big deep breath. Ready? Right, gonna take a massive breath. There we go. The solder on these is obviously some really janky lead-free solder, because it takes forever to heat up hot enough for it to come off. Right, another deep breath. Okay, there we go. Number 2. Yeah, I could help it with a little solder. If I run some 4060 on it, that would help out. Look, watch how much quicker this bottom one's going to be. If I just drop a little bit of 4060 along here. That melts a lot lower. Now I imagine that's going to be a lot quicker. There we go. There's our 3 drive ICs removed. So now we just want to freshen up those pads with some 6040. What causes these to go in the first place? So there's no dead MOSFETs on this one. The reason that these die is just a really bad design, and the rectifier diode that runs the 12 volts supply for the 2092s is way too small, and it just literally fails. Okay, so that's the pads freshened up. Now we just need 3 new 2092s, and they should be quicker to solder in than they were to desolder. Then we can just check the rest of the driver cards. One, two, three, there we go. Okay, I think that is soldered in, that one. Let's just wait for that to cool down and we can have a little visual. Yeah, it looks good. Okay, next one. Ooh. Okay, one more to go down at the bottom here. Okay, I think we're all good then. All 3 of those seem to be soldered in. Just checking each and every one of these legs. Make sure that it doesn't wobble. Make sure that it's actually soldered to the board. Yep, cool. So now that's all soldered in, what we can do is a multimeter check across all 3 of these channels, because we're looking for the numbers to be the same on the multimeter between all 3 of these channels. Then we'll know if there's any other like issues on the driver cards perhaps. So 1521, that's probably going to end up at the same number, because they're all slightly different temperatures at the moment, so the numbers will be slightly different, but we're looking for the roughly the same sort of idea. 529, yeah, that's about the same idea. 522, yeah, same idea. And then 1430, 1440. 485, 495. Yeah, I think we're looking about right now on these. So, just while we wait for that to cool down a bit more, I'm just going to go ahead and suck the solder from the holes on this driver card a little better, because some of them have a little bit too much soldering for the driver card to go back through. So I'm just going to do that real quick. There we go. I called a local audio shop to me just now, and they told me the sound wave from a ground zero is better than from a Taramps. Well, we need to know what models you're talking about, but basically if we're talking about bass amplification, then not really. And the subwoofer doesn't really care anyway. Like, honestly, the subwoofer doesn't care. As long as it's getting a sine wave in one shape or form, the fact that the Taramps might have like 0.5 or even 1% higher THD than the ground zero makes absolutely no difference to the subwoofer. It doesn't care in the slightest. What you should do when you're looking to buy a mono amplifier is you're looking for how much power can you get for the money, power for the money, and reliability. Ground zero don't have the best track record for reliability, and they don't design their own circuit boards. They're just cookie cutter designs from Korea or China. If the guy in the shop is talking about ground zero GZCA, the new full bridge ones, then actually there's kind of nonsense, because those ground zero GZCAs are actually awful amplifiers. They're Chinese clones of the sound digital circuit, and they're very poorly optimized. Ground Zero and Taramps make many different types of 3000 watt amplifier buddies, so we need to know exactly what model you're talking about, because they're all different circuit designs from all different eras. Right, let's zoom out and let's see whether we get Class D switching on all 4 channels now, shall we? I wonder. So I think all the MOSFETs are okay. We checked those already. I'm just checking between these channels now. This one that we fitted with the driver card just now. Got a slightly different value here on this one though that I'm a bit unsure about. 420. Maybe it is just temperature related, but it's quite a bit different. Okay, we're going to roll with it. We're going to roll with it and just see what it does. Okay, so positive rail. Oh, let's connect the remotes back to the board. So, positive rail, there's our positive rail. Okay, and let's check for Class D switching. Alright, we do have some Class D switching. I'm just going to zoom in on the scope so we can see that. Oh, I just saw some smoke actually coming from the board. Where did that come from? I'm pretty sure I just saw some smoke from the board, so we know that that channel just worked. That channel? Okay, nothing from that channel. So something is still wrong on this card, I believe. This one. Class D switching there. And Class D switching there. But nothing from this card, and something's getting really, really hot. Okay, so we have some work to do still on this card that I had just removed. Okay. I wonder if the 2092 was getting hot and has died. Again, the one that I just fitted that was brand new. Let's take some isopropyl alcohol and let's spray some isopropyl alcohol on the board. And what that will do is it will show us what was getting really, really hot just then. Okay, it's not the drive I see. That's not getting hot. Something on the back. I wonder if it's that 100 ohm resistor that I fitted. It does smell a bit resistory. Well, why would that be getting hot? There's no reason for that to be getting hot. It seems to get hot as soon as you put rail voltage to it. So let's see what voltage we've got either side of that resistor. So on a good card we have on one side we have our 12 volts ref neg rail, and on the other side we have also 12 volts ref neg rail. Okay. On that side we have straight up neg rail, not 12 volts ref neg rail. Okay. And I can't get to what's on the other side because there's this inductor in the way. What's up, Sedin? How's it going, buddy? What am I doing? Oh yes, right. So on this side of the rectifier diode, this side of the rectifier diode that supplies 12 volts ref neg rail should go into the driver card, on the 4th pin here. 1, 2, 3, 4, which it does. It then connects there, and then we should have 100 ohms over to this side. Okay. Very strange. So what are you unhappy about then? Why are you getting hot? What's burning? Yeah, it seems to be that that 100 ohm is getting cooked. Interesting. Now that means that we must have a short on the other side of the 100 ohm to negative rail perhaps. So that's what we're going to look for next. Or a low resistance to negative rail on the other side of that 100 ohm resistor that we fitted. So that's here. So negative rail is over here. We don't have a low resistance there. Okay. That's this transistor. That's not shorted. Okay. Now sometimes on these driver cards, these capacitors actually here for the high side bootstrap, these will actually fail. I've never seen one go short before or low resistance, but seeing as that's a failure point that I have found, we should probably check. So these surface mount caps here, I've had these known to go bad. Ah, there we go. There's our short. So a dead surface mount cap that was hiding underneath this glue was causing issues on this card. Okay. Well, I hope it didn't kill the 2092 because they're kind of expensive, but if it did, then no drama, we can just fit a new one. Actually, that might have been what killed it in the first place. That surface mount capacitor might have died in the and then this surface mount capacitor dying might have then killed the 2092, which then killed the rectifier diode for the 2092 supply, which then in turn killed all the 2092s because it was then getting AC. So that might have been what happened initially in the first place. This type of glue that they've used doesn't go conductive, so it's not the glue in this case, but you can have the glues go conductive. Right, now I hope it was the diode that was shorted, not the drive IC, because we were reading a short across those pads, but it doesn't necessarily mean it was the diode. It could have been, sorry, the capacitor. It could have just been that something on the board is shorted where that capacitor is fitted. So let's check on the board now, see whether there's a short. Ah, okay, fuck this. There is still actually a short there, so it's not probably wasn't the capacitor. Maybe the 2092 died? Why did the 2092 die again? Okay, now that capacitor is actually reading okay. I'm going to remove the 2092 and see if the short goes away. This type of glue that they've used in here, this amplifier isn't old enough to have the glue go bad like that, and this type of glue here, this doesn't really go conductive, this one. Check the carbon from the burnout. Now the board isn't really that carbonated on the back, it's fine. Carbonised on the back, it's fine. I guarantee it's fine. Right, 2092's out. Has that little short gone away? No, still got a short across those pads. Interesting, and it's about 15 ohms or something like that. So, okay, let's have a good look at this board then. What pads? Ah, hang on a minute. It's on the main board. I wonder whether there's a short on something on the main board, maybe for this channel. Well, we checked the FETs already and they were fine, so it's not the FETs. It's not something on the main board. Stuff on the back. Diodes. No. Ah, there's a capacitor on the back that is reading dead short. So it's probably that one. So I bet the 2092 was fine. I'm gonna put the 2092 back in actually, because I bet it was fine. I should have checked all the capacitors before I reloaded this driver card, but fortunately it's accessible from the top of the board here, so. Right, that's out. I can't remember off the top of my head what value that capacitor is, but I think it's, I've got a feeling it's a like a sort of 22 microfarad, so I'm going to drop a 22 microfarad in, because I've got some of those spare. Almost certain it is, because I've repaired one of these recently with the bad capacitor there. Right, there we go. If I find my replacement capacitors, I have a similar tub here. Love it. I have a similar tub here for all my caps. Love it. There we go. Here's one. There we go, that's that capacitor in. I need to drop the that cap that I removed earlier back in as well. So that's probably fine. And put the 2092 back in again. Good 8. Okay, that should be good for the 2092. Did I get that on the pads, or is that... no, I didn't quite get that on the pads. On that side, so let's just heat that back up again, push it over a little bit. There we go. Right, so does that channel now work? New capacitor. I'll just check for a short across that bottom cap there. Oh, wait, what? Why is that still shorted? It's now shorted with a lower resistance. I'm so confused. Hang on a minute. What? Oh. What? That short is still there, but it's different now. I am bamboozled right now. What is going on? What the heck is going on? Still a short across that one, but that's now lower resistance. Oh, you know what I think I did? I think I just soldered the bad cap from the back into the front in my haste. Bloody hell. What I meant to do was solder the cap that was in the front back to the front. I soldered the one that was in the back. There we go. Right, let's put that one in now. Right, check the short is gone. Yeah, short is gone, so that's just what I did. I soldered the bad cap from the back into the front location by accident. Whoops. Right, I've got to let that properly cool down now, because capacitors change their values when they get hot. So I'm just going to let that do a big cool down, and then we'll check for Class D switching, and then that'll be it. Okay, moment of truth then. Has that fixed that 4th channel? A bit of rail voltage. Do we get Class D switching? Yay! There we go, 400 kilohertz on all 4 of these channels. That, my friends, is a wrap. You can't see me because my Logitech, my fucking Canon camera has died again. But gents, thank you so much for joining. That has been an interesting stream. Sorted out the MD8000 from Taramps and sorted out this little 4-channel as well. Hopefully that was entertaining for you and interesting for a daytime stream. I'm going to go have some dinner. So guys, hope you enjoyed and have a great weekend, and I'll see you next week. Peace!